Welcome to the video for lesson 4.1 about rates and ratios. This is our first lesson in unit 4. Let's go ahead and get some vocabulary. A ratio is a comparison of two integers using division. It can be written in several ways. They're all going to be read the same, 5 to 1, 5 to 1, 5 to 1. So it can be written with the colon, the two dots in between. It can be written with literally the word 2 in between, or it can be written as a fraction as division looking like a fraction. A rate is when a ratio can be in different units of measure. Please notice that the definition of rate uses the word ratio. So it is a comparison of two integers that just happens to be in different units of measure. Most common rate for us is going to be in miles per hour. So 60 miles in every 1 hour is a rate. $100 for 3 hours is also another example of rate. A unit rate is when a rate is simplified to have a denominator of 1. The 60 miles in every 1 hour is an example of a specific unit rate, 60 miles in 1 hour. But the $100 for 3 hours would need to be simplified to about $33.33 per hour. We will focus on being able to write these in per statements. That's really the way that you know that you have a unit rate. We do not say $100 per 3 hours. We say $100 for 3 hours. But we can say 60 miles per hour, and that gives that indication that it's for every one. Let's take a look at some examples where we're simplifying ratios. We just need to make sure that they have the same units. So let's take a look at 40 green to 15 purple. That could be anything. Maybe it's like mixing up icing, 40 green drops to 15 purple drops of food coloring, or mixing up paint. Either way, the ratio is 40 green to 15 purple. I mean, it could be Christmas lights. There's 40 green Christmas lights, and then there's to every 15 purple. Like that could be the relationship. Either way, they are the same unit because they're both colors. So we just need to put them as a fraction and then simplify it. So the 40 goes on top of the 15. Order matters. 15 over 40 would be wrong. 40 over 15, simplify it by dividing by 5. You get 8 to 3. So 8 green to 3 purple. So that maybe means on a smaller batch of this icing, you only need 8 drops of green food coloring to 3 purple. Or though there may be 40 total green lights and 15 total purple lights, the pattern is actually 8 green, then 3 purple, then 8 green and 3 purple. It's just a simplified ratio. This next example compares 49 inches to 7 feet. Measurement is the same, but there are different levels of units. So we have inches to feet. So in order to accurately simplify this ratio, we first need to put them in the same unit. So I'm going to take the 7 feet, we'll multiply it by 12. So the ratio is actually 49 inches to 84 inches. Now we're dividing by 7 here simply to simplify. So 49 and 84 are both divisible by 7. So it's 7/12 or 7 to 12 inches, 7 inches to 1 foot. And we can only put it back into the 1 foot because that's what 12 inches is. But the most accurate ratio, simplified ratio, would be 7 inches to 12 inches.
Impacted each of us in each of our classrooms in very different.
Okay, I want you to go ahead and try these on your own. First one says 8 lavender to 10 peppermint. I was thinking essential oils when I came up with this one. 8 drops of lavender oil to 10 drops of peppermint oil, simplifying that ratio. 15 yards to 2 feet. You want to make sure that you definitely take their units of measure into consideration. And then we're actually going to cross this one out for now because $112 in 8 hours, we cannot relate the dollars in hours. So we will have to use that later in a rate problem as opposed to a ratio. All right, we're now going to take a closer look at unit rate. Remember, with unit rate, their units don't actually have to be the same. We just want to simplify it down to a 1. So $112 in 8 hours is how much money in 1 hour, and so on. So let's take a look at these. The thing to keep in mind with these examples is that when you are you're still going to set up a fraction, but it really is going to be division, and it may not always work out perfectly. So in this case, I'm dividing by 8, not because it just so happens that they're both multiples of 8, that they're both evenly divisible by 8. I'm dividing by 8 because that's how I turn this 8 into a 1. You're just always going to divide by this denominator because I want that number to be a 1. 8 divided by 8 is 1. It just so happens that 112 divided by 8 is a nice perfect 14. So that becomes $14 per hour. The next example, 25 letters in 5 days. Again, I'm dividing by 5 because that's the denominator in this fraction. 25 letters over 5 days. We divide by 5, that's an average of 5 letters per day. And I only say average because it's very possible in this example that maybe someone wrote 6 letters one day and 3 letters another day and 4 letters. But if 25 letters were sent over 5 days, we can say that that was 5 letters per day. That would be the unit rate, how many letters for every 1 day. And we can write that as this per statement. The last example, let's see if I can move the block again here out of the way. The last example, 166 hours over 4 weeks. Well, here's a perfect example. My answer ends up being a decimal. 166 is not evenly divisible by 4, but that does not change the fact that I will be dividing by 4. When we were simplifying ratios, we were dividing by something that could go into evenly the top and the bottom. In this case, we're just going to divide by the denominator. 4 divided by 4 is 1. So 166 divided by 4 is going to be 41.5 hours per week. So 41.5 hours in 1 week. So we can write that as this per statement, 41.5 hours per week. Again, go ahead and try these next 3 on your own. Remember, the goal is to start as a fraction and simplify that fraction in a way that turns the denominator into a 1. Notice the minimal amount of work that I have in this area because all you are really doing is dividing. Take that 1035 and divide it by 60. You get 1725. That's the math that you end up doing over and over again. So just take the numerator, divide it by the denominator, and put it as a fraction or write a per statement, $17.25 per hour. Approximately 3.3 texts per minute. Now in this case, I did make this little approximately symbol because it does not make sense to have 0.3 of a text message, but it did calculate down to that and I had to round. So I make this little double squiggly, means approximately 3.3 texts per minute. 12,680 views in 4 days, we would say that that's 670 views per day. The final set of problems in these notes is going to be using the unit rate to figure out which is the better deal economically. So in a nutshell, what we're going to be doing here is figuring out, okay, well, if 10 ounces of peanut butter costs $11.10, how does that compare to 16 ounces of peanut butter that costs $18.08? And the only way to really figure this out, which one is the better deal, is to figure out how much it's costing for 1 ounce of peanut butter in each of these situations. In order to do that, we're going to take the $11.10 and divide it by the 10, the $18.08 and divide it by the 16, because what that will give us is the dollar amount for 1 ounce for each situation. So this is $1.11 per ounce for the smaller bottle. It's $1.13 per ounce for the larger jar of peanut butter. And many times in this situation, people always think that just the bigger amount will be the better buy, simply because you're getting more. Yes, it's costing more, but most people just assume that it's costing more because of the higher amount of peanut butter and not because it's actually costing more in the unit rate. So in this example, the 10 ounce jar of peanut butter is the better deal because it's cheaper per ounce. So another example, again, $4.49 for a box of 12 fruit snacks, $4 for a box of 10. We have to figure out, okay, well, which one? We are getting more, it is costing more, but is that the only reason why this is costing 49 cents more? We need to calculate what it is costing for each of the fruit snack packs. So again, we're going to take the price and divide it by the number of items you're getting for that price. price divided by the number of items that you're getting for that price. And when we figure that out, that again is giving us the cost per snack, the cost per fruit snack. 37 cents per snack for the 12-pack fruit snacks, 40 cents in the 10-pack. So in this case, again, the better deal is going to be the 37 cents fruit snack pack. Go ahead and try these last two on your own. Paying attention to the order here, like 12 ounces of soda for 75 cents, these problems give you the dollar amount first. It doesn't matter which order they give you the information, you're always taking the dollar amount and dividing it by the number of items, in this case, number of ounces, in this case, number of pounds of meat. So in this case, the soda costing $1.15 for the 20 ounces is the better deal than the 12 ounces of soda for 75 cents. And for the pounds of meat, the $8.99 per pound so the 5 pounds for $44.95 is the better deal than 7 pounds for the $63.35. I want to wrap this up with just a real quick look at what happens when we put the money in the denominator of these rates. So like 5 pounds for $44.95. The problem here is that, remember, the unit rate has to have a denominator of 1. So what you're really calculating when you do that is how many pounds of meat can you get for $1. And that's not how we buy things in the grocery store. You don't walk up with $1 and say, give me the amount of roast beef that I can get with this $1. You have to have the money to buy by the pound. How much money do I need for that 1 pound? So in this case, you can still calculate it out, but it ends up being 0.11, and that's rounded for $1. So again, this is just over 1/10 of a pound per dollar. You can say it as a rate. This is just not how we run things in the grocery store, just not how we do the calculations. It's how much money for one item.